Hi everyone, thank you for joining us today. I look at the list of the participants here, and I see some familiar names. So thank you for joining us. We're really happy to have you. My name is Amit. I'm the product owner of WebScraper API. Today I'm going to show you how to use it, how it works, and some cool features that we have there. Just know this session is recorded, so you'll be able to watch it later too. If there are any questions, you can, during the demonstration, you can write in the chat here. We have Lucas here, is the technical expert. He will answer the questions on the fly during the demonstration. And we will also have some time in the end for more questions if needed. So before we start the demonstration, I want to give you like a quick overview about the WebScraper API. And how is it actually different from using proxies for scraping? So a little bit about the product. The WebScraper API is a solution that is all about simplifying and accelerating the web data collection. Our scrapers offer a powerful and flexible way to extract structured data without the ongoing maintenance of managing proxies or dealing with anti-bot measures, fingerprinting, unlocking, or even writing complex scraper code. All of these are not needed for the WebScraper API. All of them are on us. So another thing about the WebScraper, it's also support a lot of domains from various verticals like e-commerce platform, job boards, real estate listings, and even starting recently, also AI chatbots. We also scrape these. And I will also show an example about it. So how is it different from proxies? So I'm a little bit biased because this is my product and I'm really proud of it, but there are a lot of advantages for the WebScraper API in terms of maintenance. So basically, maintenance is needed for proxies and for maintaining the scraper and parser codes. Supporting new domains can end up being a lot of work for when we use a proxy-based scraper, because you need to maintain everything all the time. You need to check the unlocking logic. You need to check the scraper logic. One day you wake up and the website that you're targeting changed the layout entirely. So you need to now look at new CSS selectors that you need to scrape. And all of this takes a lot of time, a lot of resources. In WebScraper API, you get everything on us, meaning we maintain it, we write the code, we support the unlocking logic, we maintain it regularly, meaning all you need to do basically is just send an API request with your inputs and you will get the results. The best thing about this, the best advantage, in my opinion, is the fact that from the moment you open an account with Bright Data until you can get your first data result, it's a matter of minutes. You can do it really quick with just one API code. So now we'll show, we'll soon start the demonstration and you will see how easy it is. Also, there's the point of pricing, which you pay only for data you get. So it's probably the most cost-effective way to test it. Now, before I move over, I want to say, again, I'm biased because this is my product, but there are some advantages for proxy-based scrapers, and it's all up to you to decide what is more important. For example, in proxy-based scrapers, you retain full control and flexibility of your operations, which is a good advantage. But personally, I think the scraper API gives a lot of more value that that can be can save a lot of resources and a lot of headache. So before we get into the demonstration itself, I'm going to show you a little bit of the types of the endpoints that we have, the endpoints and scrapers. The PDP endpoints, it's about sending a single input, a single URL. Doesn't have to be single, like you can send many URLs, but the fact is that you send one input and you get one record for it. So it's, for example, for product pages and social media profiles, social media posts, stuff like this. You send one URL, you get one record in return. The discovery endpoints is a little bit different. With discovery endpoints, the discovery is for finding the URLs themselves. So it usually expects like a search result page, and then it go over all the page, take all the items from the list, and then return the URLs. Now, after it returns the URLs, it pushes them directly to the PDPN. Meaning, let's talk about a short example. If you have Amazon search result page, and you use the keyword like electronics, then it will search for electronics in Amazon and return all the product that it can find from the list. And then it will go to each of these products and scrape the product page for the name, description, price. We have a lot of data points. We will see it in the example later. Another thing is the option to send requests in real time or in async mode. So in synchronous mode, you can see here, we use the scrape endpoint. This returns immediate results, meaning you send a request from your terminal, you get the record back to your terminal. This is, for example, best for applications that need real-time data, like live pricing, stock availability, real-time reviews. The use cases are endless. And it's better to use this endpoint with small, lightweight jobs that should return quickly and be presented somewhere live. The async request, on the other hand, when we call this endpoint, this is the trigger endpoint. It starts the job and returns immediately a snapshot ID. This snapshot ID can be used later to review the progress or to download the data after the job is finished. Obviously, you can also automatically deliver the results to storage after the job is done. You don't need to manually download it every time. This is better for big jobs that will take a lot of time, that are not needed immediately, or for schedule scraping job. Like if you want to scrape something once a week, specific product, specific profiles, anyway. Now I will start the demonstration. This is before we start, does anyone have any questions? See, the chat is empty. So I'll continue for now, and we can have another Q&A section in the end. So this is the web scraper library. Here you can find the domains that we support. Once you choose a domain, you will get to a page that shows all the endpoints that are available for this domain. Each endpoint is a different scraper that scrapes a different data or scrape it in a different method. So let's check the first example. This example is the LinkedIn profile, people profile, collect by URL. What does it mean? First, you can see here we have a lot of scrapers for LinkedIn. In this demonstration, and we look at the profile scrape. So this scraper basically expects a URL, a profile URL, and he will get back all the info that we can get from the profile, all the data. So let's test it live. I have the code here. You should note that the API key, it should be here if you open an account, it should be automatically. But if for some reason you don't have the API key, you can get it from the account settings. It takes a minute. Anyway, we will start the scraper. And actually for this demonstration, I will use the scrape endpoint, which is the real-time one, meaning I will send this request and I should get the data immediately to the command prompt. Until the data will come, will arrive in the terminal, we can look at this page. Basically, you can set up your scraping operation here. We have a lot of features here. For example, include errors with the report for pages that didn't come back for some reason, deliver results to external storage. It's pretty straightforward. We're not going to cover it today, but you can check it out when you test the product, or send the data to webhook, or choosing a specific schema to return, meaning you don't have to return all the data. You can just return some of it. So 1 second. This is the snapshot page. I see now the request I sent was not sent correctly. Once you run a snapshot, once you run an API call, you will be able to see the running snapshot live in this table. One moment. You could see this snapshot is running. And once it finishes, we will see the results right over here. Oh, it's done. So you can see, I'm not going to go over all the data here, but you can see the ID. This is the LinkedIn profile of Bill Gates, what I checked. And you can see how much data we got only from one request with one input. Imagine what you could do with 10,000 of profiles. How much data can you get? Okay, for the next example, I want to show something a little bit different. This here, I will use the trigger endpoint to initiate a snapshot that will run asynchronously and will give me a snapshot ID I can use later to check the progress. And this is Amazon Products Discovery by Keyword Scraper. So what does this scraper actually do? It takes a keyword. I think I mentioned this example earlier when I explained the discovery. It takes a keyword, it puts it in the Amazon search bar, runs, and then returns all outputs, all records it can find. Since we don't want it to take too long, I'll just limit it to five records. So we should stop after 5. Then I will take this code and run it here. Second. You see, the second I sent it, I get a snapshot ID, the same snapshot ID that I will see here, which is running. Since it can take a few minutes to scrape a bunch of products, I ran it before, so you can see how the data looks quickly right after I run it. I ran it the same request, like five product from Amazon discovered by Keyword Scraper. This is the JSON. Let me just order it one. Okay, so as you can see, this is for all the products for headphones. So this is the discovery. And a third example I want to show you. It's something that becomes really popular recently, and we want to show this too because we managed to start scraping AI scrapers. So What are the AI scrapers? Basically, the same way that you go to ChatGPT and write a prompt, you can do it using your scraper, sending thousands of prompts and getting their answers directly from ChatGPT. Same with Perplexity and Copilot, of course. We support all three of them right now, and we are working on more. This opens a lot of use cases from scraping related use cases that we had even before the AI bots that we have today. Right now, they are being used to SEO, travel, e-commerce, market research, competitive intelligence, and the most important one, training AI models. We have a lot of customers that are using these scrapers to train their own models, to check, to see how ChatGPT answers a specific prompt, how Perplexity answers the same prompt, and how their model answers the prompt. This is how they know to, how to train efficiently their models. And there are a lot of more use cases, and it's a really cool new use case that people are really that becomes really popular recently. So let's see how it works. In this specific example, I'm using what we call the no-code scraper. So basically, it's the same thing exactly as the web scraper API, just that you don't even need to use the API. You can set up the request that you need on the UI and click here in the Start Collecting button, getting the data directly to the UI and downloading it. Also here, you can also define delivery settings and send it directly to storage. But the no-code scraper is basically more for testing or a little less technical people that don't want to handle API now. We just need like quick data. So let's see the ChatGPT scraper. We have here a lot of inputs that can help getting more accurate results according to what you're trying to find. For now, we won't touch them. I'm just using the prompt, top 3 smartphones, 2025. Clicking start. Now, it also may take a few seconds, usually less than a minute, but I really want to show you how it looks. So I also prepared. So the ChatGPT scraper not only returns the prompts, the answers to the prompts, it also returns the HTML itself. As you know, for example, in ChatGPT, there is it can return maps, it can return products, it can return like markdown content, like instructions how to do stuffing or bullet points and stuff. And for research purposes, these formats could be very important to understand how ChatGPT structures its own data. So here, we're not only getting the answer text, we also get the HTML, we also get it in markdown format, and we also get the citations used for web search. So if it search the web, we also return all the sources that it used. This data is insanely useful for research in any field. So this is the AI example, and these are the, and I showed you today also yes, sorry. So we saw an example for a PDP scraper for LinkedIn, which we saw, which we used in real time, and we saw it returns all the data directly to the terminal. We saw a discovery scraper for Amazon with the trigger endpoint that ran the job asynchronously, and once it finished, it returned back to we saw it on the control panel, and we downloaded the file. And we saw the ChatGPT scraper, which becomes really popular. Now, this is the end of my section for this demo. I will return later for Q&A. For now, I want to introduce Meir. Meir is our AI engineer, and he worked on a really cool product. It's Bright Data MCP. Meir, take it from here.
Thanks, Amit. Hi, everyone. As Amit mentioned, I'm the AI engineer at Bright Data. Let me share my screen real quick. Okay. Sorry. Okay, so today we're going to talk about the MCP, which if you've missed the buzz, MCP is a new protocol for GenAI applications that lets them interact seamlessly with external data sources and tools. One of the most powerful data sources is, of course, the web. So we've built an MCP server for the entire web. Our MCP is already wired into 59 Bright data tools, including SERP, browser, unlocker, and almost every web scraper API endpoint from the ones that Amit just showed you. So let's jump straight into a few live examples using Cloud Desktop. So as you can see, here I'm connected to Bright Data Tools. You can see, for example, every web data tool here is a web scraper API endpoint. So as you can see, we have many different web scraper API endpoints. Let's put it to a live test. I want to show you, for example, a comparison between shoes. So let's type. And while it runs, I want to share with you that these tools, because they run on an LLM, run with the help of LLM, they are unpredictable. So one time I'm sending a prompt and it can use the web scraper API, as you can see right here. And in other times, it can use totally different tools. So as you can see, here I got the response from the web scraper API, which searched a discovery endpoint from the ones that Amit showed you. And it found a list of Nike Panda Dunk shoes. Then it searched the same way. It searched the same query, but in a different way. It uses now search engine, which is the SERP API, and it uses Google. So here the results returned as Markdown, and as you can see, we've got the results fairly quick. And now we can see that it generates the comparison after even two different initiations of the web scraper API of Walmart products. This is the PDP endpoint, product page endpoint, as you can see, and it's generated a whole comparison and prices of these type of shoes for men, women, kids. So as I mentioned earlier, the MCP includes many different tools, and one of them is a browser. So this one I made upfront to avoid issues. So I want to show you exactly what happens when we're running a headless browser through the MCP through Cloud Desktop. Here we searched for a specific type of TV on Best Buy. It knew exactly what to do. It went to Best Buy, waited for the specific selector, took a screenshot to understand exactly what's in the page, and provided us with everything we need to know. including the price that we asked for. And one last thing, let's show you how it behaves without our MCP. So I'll turn it off and I will ask the same question. And as you can assume, it won't be able to access the internet. Now, yes, the new version of Claude Desktop and ChatGPT already comes with web search, but if you're playing with plain APIs, so you won't have access to the internet, and MCP is definitely the easiest way and safest way and scalable way of doing so. So I highly suggest using it. As you can see, it's very cool. And we only touched the tip, the really tip of the tail of what MCP is and what Bright Data MCP can do. So you can go to brightdata.com, search our docs, and you can find every relevant information about this product there. Thank you, everyone.
Thank you, Meir. It's always good to learn more about AI and how it works, especially in the MCP context. So reach the end of the demonstration. I'm going to go over questions from the chat and answer them. There are really good questions here, so I want to answer them live. First question, difference between this product and the Web Unlocker API. So it's a good question. The Web Unlocker API returns most of the time HTML, and that's it. The web scraper API returns the data already parsed. As I showed you in the JSON examples from before, you already get the data, you don't need to parse it. So this is the main advantage of the web scraper API. Also, web scraper API supports a lot of supports like more cases than Web Unlocker, meaning you can the web scraper itself behind the scenes goes clicks buttons, scrolling, revealing more data in the page, and then he collects it. So this is something that is not available in the Web Unlocker API, at least not in most sites. Second question, what's the typical latency for a scraper job and how does it scale with volume? So it depends on the website. Each website behaves differently. Some take a lot of time to load, some take less. Also, it's the whole thing with the unlocking and accessing the page, and also interactions within the page, clicking, scrolling. Basically, it's very dependent on a lot of factors. But basically, the more inputs that you will send, the less time per input per record that you will get in the end, because we parallelize most of the requests, most of the jobs. So it's better usually if there's a lot of volume and high scale to send it in batch mode. How do you associate, next question, how do you associate the search content with the target page? Do I have to provide a website that has a search bar? So in discovery context, it doesn't have to be a website with a search bar. It has to be, it's not like you're going to find a scraper within a library for the specific site you want, and the discovery options will be there for you. If the site that you need does not exist or does not have the discovery option, you can always ask for it. And we will build it. We will build it. But basically, the discovery works with keyword search. It can be like a URL also, a URL of a specific category in a retail site. For example, kitchenware in Home Depot, for example. So it can be like a category, and then I want to get all the records from this category. And basically, discovery means that I'm going to send some page and get a lot of results that I can find in this page. So it doesn't have to be a search bar. It can be like category. It can be, there are a lot of different things. I hope it's clear about the discovery. I see another question. What's the advantage of using your scraper of AI tools over using their native APIs, i.e. OpenAI APIs? So this is a great question. We actually checked it and compared both of the products. And the main difference is that OpenAI's API charges you per tokens in the answer, in the prompt and in the answer from the model. So the longer the answers and the prompts and the answers, the more you'll pay. In Braille Data, you get a flat rate. You pay in the pay-as-you-go package, you pay $1.50 for 1,000 requests, 1,000 inputs, records, no matter how long the answers and the prompts do. So this is one advantage for Braille Data. If you know that you need longer questions and answers, then it's better to use it will be more cost effective through Braille Data. Another thing that I found there is that they have rate limits for amount of concurrent requests. We don't have, you can send as many inputs as you want. I mean, it may take a while to get back, but we will never tell you like you have too many inputs. You can send as many inputs as you want. There is a thing about concurrent sessions, but within a session you can send almost any amount of inputs that you want, like up to 1 gigabyte of a file. So it's a lot of inputs. And these are the main differences that we found. I can say that the OpenAI API is probably faster, but the ChatGPT scraper that we have has great performance. I don't remember the exact numbers right now, but it works well, and so far customers are satisfied. Can the web scraper API handle login scenarios? So also great question. No, in Braille Data, we don't collect anything behind login. We collect only public data that is available without login. For example, if you can see it with opening an incognito window without logging in anywhere, then we can probably scrape it. But anything that requires login or some kind of identification, we don't do, and it also won't be supported. So happy to clarify about that. How does the performance of this compare to browser use with headless automation? So again, it really depends on a lot of factors. To be honest, I haven't tested the web scraper API against the browser use with the headless browsers. I mean, I haven't tested it with the same exact scenario, but it basically works like in the background, kind of in the same way. Sometimes it depends. Sometimes we need a browser, sometimes we don't. But we usually we're aspiring to have the best performance for each scraper. So it means we're always optimizing the scrapers to get the data as fast as they can. If we can get it from the network, like from a request that we find that we can catch when we open the site, instead of waiting it for the load to the page, we do it. So some scrapers that work this way work really fast, and some scrapers are working more slowly. It depends on the site and the defense that the site has. Some sites are really hard to crack, but we try to support everything that we can, everything that customers ask us for, popular sites from across all verticals, and we also maintain everything to keep it running smoothly. Okay, so I see there are no more questions. So this is the last chance to ask something. And if there are more questions, so I want to thank all of you for coming today. I really couldn't recommend more the Web Scraper API. It's a really cool product. It's here to make your lives much easier when handling scraping operations. It should save a lot of resources and time and headache of maintenance. So I hope you found this demonstration valuable. And we prepared some links, important links that will be sent to you after this demo, including my personal email if you want to send some feedback about the product or about the demo, you're all welcome. And also Meir's email if you have questions about the MCP. Thank you, everyone.